Okay, so we're going to look at how to solve systems of a linear and a quadratic. So if you notice right here, we have these two functions, the y equals and then the y minus x. And so whenever we're solving these algebraically, we want to look at how to sub in one to another. So for example, this right here is what my y is equal to. So I can sub it in for that y. So when I do that, first thing is always make sure this equation this x squared minus 6x sine is equal to the standard form, because if it's not, you want to multiply that out. So this is the standard form. We're gonna sub it into my y. So I'm gonna have 2x squared minus 6x minus 9, and then I'm going to continue with minus x equals negative 5. So once we do this, now notice the only thing that we have there is an x, so we're going to solve for x, and the way that we can do this is by completing the square, quadratic formula, or fraction. And so let's first, we're going to add 5, so I'm going to make this into standard form to see what our best option is. So I've got 2x squared minus 6x minus x is going to become negative 7x. And then negative 9 plus 5 is going to become minus 4. And this equals 0. Well, a lot of your first options are going to be quadratic formulas. And so if that's what you want to do, that's fine. I'm going to show you how to check for fraction as well. So when we're doing fraction, again, you're always going to look for GCF or GCF. I'm going to come over here and I'm going to do a times c with creating that x. A times c, so 2 times negative 4 is that negative 8x squared. And then my b value is that minus 7x. Okay, so my factors of negative 8 are 1 and 8, 2 and 4. So my goal is to see, can I combine to get a negative 7 and multiply to get a negative 8? So if I do positive 1 and then negative 8, that gives me negative 7 as well as the negative 8. So this is going to be 1x minus 8x. So now that I have that, I'm going to use that to split my b term. So this is going to become, right here, 2x squared, but instead of minus 7x, we're going to put plus x minus 8x, and then bring down that minus 4 equals 0. And then I'm going to group my first two, group my second two. My first two have an x in common, and then I have 2x plus 1 left. My second two have a minus 4 in common, and then I have the negative, oh, not 8, sorry about that. The 2x, and then plus 1. Remember, all you're doing is just, oh, I said 1 and then I wrote 4, my bad. All you're doing is just looking for the GCF between the two terms and then factoring that out of there. So now my parentheses are the same. That is one of my factors, which is 2x plus 1. My other factor is x minus 4 equals 0. And then I set both those factors equal to 0. So 2x plus 1 equals 0. X minus 4 equals 0. Well, I subtract 1. So I have 2x equals negative 1. So then divide by 2. X equals negative 1/2. Over here, I'm going to add 4. So x equals 4. So if you did this by the quadratic formula, you should get those same exact solutions. Okay, so now, again, you're not done. You can't just box this because my system was made up of an x and a y. So when I have my x and I have my y here, I need to get both of those there. So I have my 2x values. I still need to find the y. You can use whichever equation to plug it in. It doesn't matter. Most of the time when we were solving these in class, we chose the second equation just because it was shorter and didn't have the square term. So remember, my two solutions was x equals negative 1/2 and x equals 4. Okay, so I'm going to plug both those in to find my y value. So the first one, I've got y minus negative 1/2 equals negative 5. So y equals, and you can plug that in your calculator. This is a positive 1/2, which means I'm going to subtract it over. So I'm going to do 5 minus 1 divided by 2 equals 4.5. So that is one of my answers, is 4.5. So that gives me a solution point. So my solution for 1 is the point negative 1/2, comma 4.5. And because those are nice, okay, decimals, that's fine. We use a decimal, so if you didn't have negative 1/2, if you have negative 0.5, that works as well. The other one is going to be y minus 4 equals negative 5. I'm going to add 4 to both sides. So y equals negative 1. So my other solution is 4, comma negative 1. And then this is my answer right here. Okay, let's look at another one. So this one right here, notice both of them are y equals. So since both of them are y equals, we're just going to set them equal to each other. So I'm going to have the negative x squared plus 2x plus 7 equals 2x plus 1. We can move this either way, but our goal is to try to get this into standard form to see what we can do. So we're going to subtract 2x and subtract 1, subtract 2x, subtract 1. Then this right here is going to become negative x squared. These are going to cancel. 7 minus 1 is going to be plus 6 equals 0. So there's a couple different ways that you could do this. Again, you could try to factor it. It's not factorable, but you could try to check. You could use completing the square, which some of you might want to do that, or we could just use quadratic formula. So the quadratic formula, again, just a reminder, is, I'm going to write it down here, x equals negative b plus or minus the square root of b squared minus 4ac. All of this is over 2a. So what I'm going to do is I want to identify each of these letters. So a in this case is going to be negative 1 because this is negative 1. B is 0 because it's not there. And then C is just 6. And I want to come up here and now plug this in. So x equals negative 0 plus or minus the square root of 0 squared minus 4 times a, which is negative 1 times 6. All of this is over 2 times negative 1. Okay, well, negative 0 is just 0. So this is like saying x equals 0 plus or minus the square root of. In our calculator, we're going to plug exactly that in. So 0 squared minus 4 times negative 1 times 6. Hit enter, and we get 24. So what's under my radical is 24 over 2 times negative 1, which is negative 2. Well, 24 is not a perfect square, so I said in this case we could look at the decimal. So this is like saying 0 plus the square root of 24 over negative 2, and x equals 0 minus the square root of 24 over negative 2. So come over here. Remember, alpha y equals is one way that we can plug this in. We can do 0 plus the square root of 24 over negative 2. Hit enter, and we get negative 2.45. We're going to round it to the nearest hundredth. So x equals negative 2.45. X equals, now we're going to do the same thing. So the shortcut is just to hit second, enter. Go back, and we're going to change that plus to a minus. Hit enter. And now we have a positive 2.45. So that gave me my two x values. The last thing I need to do is get my y value. And I'm going to use this first equation here. So I'm going to do y equals 2 times negative 2.45 plus 1. Y equals, so come over here, plug that in my calculator, 2 parentheses negative 2.45 parentheses, and then plus 1. Hit enter. I get negative 3.9. Same thing, y equals 2 times 2.45 plus 1. Over here, 2 parentheses 2.45 parentheses plus 1, enter, and I get 5.9. So again, if I'm going to write this as a solution, my solution to this is the point when x is negative 2.45, my y is negative 3.9. And then when my x is 2.45, my y is 5.9. Remember, you can check this on your calculator using that second trace intersect, and I would highly suggest you do that. That's, again, this is solving the quadratic system with a linear equation as well as what these two problems were.